Hey, Math 8. So yesterday we looked at situations, actual situations that we wrote linear equations for. Today we're going to take the next step. We are going to do section 6.2, which involves writing a linear equation to represent a table of ordered pairs. So let's get started. So it says yesterday we looked at situations that led to linear equations. Today we want to look at a table of ordered pairs and find the linear equation that models the table. All right, this is not a hard skill, as you will see. Remember, to write a linear equation, you need to find the two key elements that every linear equation has. We went over these yesterday. They are the beginning amount and how much it increases or decreases each time. All right, we represent this with the letter M. We represent this with the letter B. Remember that from yesterday? So let's look at an example like we did yesterday and see how this will relate to a table. It says Jill planted a new tree in her yard. When she planted it as a sapling, it had a height of 3 feet. Every year after she planted it, the tree grew 2 feet each year. So it looks like on my graph, the beginning amount after 0 years, the day she planted it, it has a height of 3. And every year after, it grew 2. So when I get to 1 year, it grew 2 feet, and it's up to 5. And another year, another 2 feet. Another year, another 2 feet. And I am up to that. And I could draw a line through this to show its continued growth. But really the important thing is the points and how they line up in a straight line. And therefore, this is a linear situation because it has a beginning amount and it goes up by the same amount each time. All right, so yesterday we kind of looked at how to put these points on a table. All right, so like our X value is years, and our Y value is the height of the tree. And we know from the problem that after 0 years, the height of the tree was 3. And after 1 year, it had grown 2 feet and it was 5. And after 2 years, it was 7. And 3 years, it was 9. And these are just the same ordered pairs that are here on the graph. I've just taken the ordered pairs and I've put them in a table. And we will get back to the table, but how do we write an equation? So do you remember our formula for a linear equation? All linear equations can look like this, where the B represents the beginning amount and the N represents the increase. So what would our linear equation be for this situation? It would be Y equals, the beginning amount is 3, and we're increasing by 2 each year, right? The X represents each year, the number of years. That's our equation. So what we'd like to be able to do is we'd like to be able to, go with this weird color. We'd like to be able to get rid of the problem. We'd like to be able to get rid of the graph and just look at a table and from the table figure out the equation, right? And that is what we're going to look at today. We want to just look at a table and find the equation that models the table. So if you're going to do that, the real question is, where do we find the two key elements in the table, right? Am I able to look at a table and find the beginning amount? Am I able to look at a table and find the amount of increase each time? Well, sure. The beginning amount. Where do you find the beginning amount? It is the y value when x equals 0, right? Look back at our table we had. The beginning height of the tree is right here. The beginning height was 3 after 0 years, right? It was the beginning amount because it was after 0 years. Anytime x is 0, the y value gives you the beginning amount. And what is the amount of increase or decrease each time? Well, this is not easy to write as a sentence, but technically this is what you do. Subtract any y value minus the previous y value. Subtract any y value minus the previous y value. For example, back here, if I take any y value and I subtract the previous y value, 5 minus 3, I get the amount of increase each time. It's going up by 2 each time. You know, usually you can just look at the table and you can say 3 to 5, oh, it went up 2. 5 to 7, it went up 2. But technically, this is what you're doing. You would subtract to find it, right? Okay, so we're going to try some. So for each example, we want to find the linear equation. So where do we find these things? Well, we need to find the two things, right? What's the beginning amount? The beginning amount in this table is right here. It's the y value when x equals 0. And how much is it going up each time? Well, obviously it's going up by 4 each time. So my equation would be, I would substitute the beginning amount in for b, and I would substitute how much it's going up each time in for m, and this is the equation that represents that table. I could check it, you know, if I take the number 3 and I put it in for x, do I get 19? Does 7 plus 4 times 3 equal 19? It does. This equation would generate that table. All right, how about the second one? What is the equation? Well, of course, here's the beginning amount, right? That is the y value when x is 0. And this one is actually going down 7 each time. So what would my equation be? Y equals the beginning amount, and this time it would be minus 7x, because it's going down 7, right? This one is decreasing instead of increasing. All right, the next example gets a little bit tougher. So I'm looking for the beginning amount, and there is no x equals 0. So how am I going to find the beginning amount if I don't have the x equals 0? Because I need the y value when x equals 0. So I claim that often you can work your way backwards in a table, right? 4, 3, 2, 1, 0. And I can work this pattern backwards to get what the y value would be when x equals 0. It looks like this is going up 3 each time. So what would go here? Let's see. Well, if I go backwards, I'm going to subtract 3. So this would be 10, right? when x equals 0, this would be the beginning amount. And then when I go this way, I'm adding 3 each time. So this is the amount of increase. And so I know my beginning amount, and I can write my equation. It would be y equals the beginning amount, and this would be plus 3x. And one more, see if you can get it before I do. So again, I need to work my way backwards. I need to know what is the y value when x is 0. So let's see, it looks like this time it's going up by 6. So if I go backwards and I go down by 6, this would be negative 2, right? It would be 4 minus 6, which is negative 2. So this is the beginning amount, and the increase is 6 each time. So my equation would be negative 2 plus 6x. All right, so you got those. Let's look at one more thing and we're done. We want to be able to look at a graph and determine for what x values, this is important, for what x values the graph is linear or nonlinear and increasing or decreasing. So first I've given you some notes about linear and nonlinear. Linear graphs make a line. Nonlinear graphs, they curve. That wasn't very good. All right, so if it makes a line, it's linear, and if it curves, it's nonlinear. And what about increasing or decreasing? So increasing graphs go up from left to right, and decreasing graphs go down from left to right. So, increasing graphs go up, decreasing graphs go down from left to right. We should be good. Let's look at what these problems look like. Now, the first thing I want to make sure you know is, do you know what this means? I want to review that with you for a second. That is called an interval. And it's telling you something about the x. It's telling you x is between 4 and 9. Technically it's saying x is greater than 4 and x is less than 9, which means x is between 4 and 9. It's a fancy way to write two inequalities. It's called an interval. So you need to remember that. And we're going to try these problems. Now, the grid did not show up very well on here, and that's okay. We don't really need it that badly. I'm saying the lines on the graph paper did not show up. The first thing I want you to recognize is that we, let's see, pay attention to how the x values name parts of the graph. So when you name parts of a graph, you use the x values. Let me show you. I'm going to go to each dot here on the graph, and I'm going to draw a line down to the x values, or up. Okay, what this does is it sections off parts of the graph. So like between these two, this is x equals -9 to x equals -3. And then this part, now if I wanted to write this as an interval, it would be -3 is less than x is less than 2. It's going from -3 to 2, right? And then I have from 2 up to 6. That's my next interval. and from 6 up to 9. So we want to be able to name the parts of the graph based on the x values. And the question here is, on which interval is the function decreasing, so it's going down, and nonlinear, so it curves? Well, the first section goes up, so that's not it. The next section goes down, so it's decreasing, but it's linear because it makes a line. Then I have the section we want, it looks like. This section right here goes down, so it's decreasing, and it curves, so it's nonlinear. So I have found my section of the graph. On which interval? It would be from 2 to 6. And which one of these says? So it'd be this one. When x is between 2 and 6, the graph is decreasing and nonlinear. Do we follow that? Let's try one more. This one kind of reverses the question. What is true about the function on the interval 4 to 9? So where is the interval 4 to 9? Well, here's 4, and here's 9. So we're talking about this part of the graph right here. Right? That's the part that goes from 4 to 9. And what do we know about that? Is it increasing or decreasing? Well, of course, it's increasing because it's going up. And is it linear or nonlinear? Well, it makes a straight line, so it's linear. It's increasing and linear. So of my choices down here, it would be the first one, increasing and linear. All right. So we've written, you've learned how to write an equation by looking at a table. And you've learned about graphs and how to name an interval on a graph based on being linear, nonlinear, and increasing or decreasing. I think you'll have no problem with the homework, and I will see you guys later.